Okay, so now we're here with section 1-2, measuring segments. So this is topic 1, section 2 in our geometry textbook. So first off, we're going to be talking about the word congruent. Now congruent means equal. I'm going to be asking that a lot this year. What does congruent mean? Equal. So every time you hear me ask, what does congruent mean? You should always say equal. It means they have the same length. And this is our symbol for congruence. Okay, it's just an equal sign with a squiggle above it. Okay, so that is congruent. It means they have the same length. So on segments, because we're talking about segments in this section, when we're talking about congruent segments, they have these little dash marks, okay? So whenever we see a picture, whenever it gives us a picture, every time we see dash marks, we should automatically think those are congruent, which means that they're equal. So that is congruence. And oftentimes there'll be those dash marks to tell you, even if it's not in the problem. Or it'll say something along the lines of segment AC. Remember, we have to put the little bar over it if we want to call it a segment. You can't just write AC with nothing in front of it, nothing above it, nothing around it, okay? So I could say AC is congruent to CB, okay? So that is my statement there. AC is congruent to CB. Those are both segments that are congruent because the dash marks tell us. Now, next up, we have what a midpoint or bisector is. So now midpoint and bisector, these are kind of the same idea for the most part. It cuts something in half. So I need you guys to understand that. A midpoint and bisector, they cut something in half. And what do we know about something that's cut in half? Both halves are equal, right? So we can see on here that the segment AB was cut in half and its midpoint is C. And we know that because these are two equal parts. And so you see this right here where it says M equals B. This is our first introduction to something we call reasons. And sometimes I put them in parentheses, sometimes I don't. So whenever you're wanting to write an equation for this, and you're wanting to say, like, let's say AC was 2 and BC was, let's just say 2x. Let's 2x. And we're like, what is x? Now, for you to be able to say that we can set these equal to each other, 2 equals 2x, to figure out that x is 1, the reason for why we were able to set up that equation was because of midpoint equals bisector, okay? That's the abbreviation for a reason. Now, a lot of geometry is you explaining why you're doing something, okay? And so that's our explanation. So that way you don't have to write out all the words of midpoint and bisector. This is the shorter way of writing that for my class, okay? Just to make our lives easier and not have to write out all of that each time. So then let's talk about measuring segments. When we're on a number line, okay, like how we have a number line here, we can do the big number minus the little number, okay? So big minus little. Or we can just count. So that's two ways to do it. So the big number, especially on a number line, is always going to be the one to the right. So even if this was like 6 and this was negative 15, 6 would still be the bigger number, okay? It's positive. The positive number is always going to be the bigger number. So I have to do big minus little, okay? Or we can just count. We can go 1, 2, 3, 4, 5, 6, 7, 8 to count how far the length of this segment. Now, please make sure you don't start counting 1, 2, 3. That's not how you count. You count when you move. So you start here and then you go 1, 2. Make sure you count properly if you're just counting. And here's the example of doing big minus little. I can do 6 minus negative 2. When we subtract a negative, it becomes 6 plus 2, and we also get 8. So there are two different ways we can measure segments. Now I want to talk about the midpoint formula. So this is when we have 2 points, such as A is at -2 and B is at 6. We can use the midpoint formula. And this is just the same as the mean or the average of these two numbers, okay? All we do is add them together and then divide by 2. So in this case, I have 6 and -2. Now, it does not matter which one goes first. When you're measuring it, you have to do the big number first minus the little number, or you have to take the absolute value. But for midpoint formula, you do not have to put them in any particular order. You could switch these two numbers. It's the same thing because it's addition. And we get that our midpoint is at 2. And what I'm talking about with the big minus little, we could do little minus big, but it would have to be the absolute value of that. Because if I did -2 minus 6, I would get -8. Now, can distance ever be negative? No. So I would need absolute value symbols, if you've learned that in Algebra 1. So our distance is actually 8, okay? Distance is never negative, okay? So if you get a negative distance, you can either switch the two numbers around, so you do big minus little, or you can take the absolute value as long as you are using the correct two numbers. So, but that is a key idea here, okay? So now let's talk about, so we talked about midpoint formula. Now let's talk about segment addition postulate, okay? It's a really fancy word. Postulate is just another fact, okay? It's just something to acknowledge what is happening here. So if 3 points are collinear, now if we remember back to 1-1, what collinear means, it means line or points that lie on the same line. That's what the linear is, on the same line. So if any 3 points are on the same line, so as long as they're all touching a line, then this part is true. Segment AB plus segment BC equals segment AC. Now, I write this down as a part plus a part equals the whole. And that makes sense, but that's a lot to write out. And so is segment addition postulate. That's a lot to write out. So we abbreviate this to part plus part equals whole. So let me pretend and give some numbers here. So let's say AB equals 5 and BC equals 7. And I said, what is AC equal? Question mark. Okay. So, this is pretty simple here, very clearly. AB is 5, BC is 7. We can do this part plus this part, 5 plus 7, to get our whole. So we can say AC, segment AC equals 12 because of part plus part equals whole. That is the shorter way to say segment addition postulate. Instead of writing all of that out, you always have to write these reasons down. When you are doing these practice problems, which I'll get to in a moment, you need to write down your reason for getting your answer. And this works backwards too, so let me explain that real fast. What if I told you AC equals, let's go with 20, and BC equals 14, and I wanted to know what AB is, okay? Now, here's the thing. It says set up equations. I always recommend you set up equations. We can still set up the same thing. AB, which we don't know, so what letter should we use for something we don't know? We can use an X plus BC, which we know is 14, equals our whole, so part plus part equals whole, which is 20. Now, it may seem ridiculous to take the time to write it out like this. You may be like, oh, I can just do that in my head. But these are just a very simple example of what this problem will look like, okay? So then we solve the equation, right? And we get that x equals 6. That's what AB equals. And you could even write AB in here. You can write this equals 6, however you want to do it. But what's our reasoning for why we could do this? It was part plus part equals whole. On every single problem, you need to write what your reason is for solving your problem that way. I won't make you write out the whole segment addition postulate, but you have to at least write out this stuff in parentheses. Whether you're using midpoint bisector or segment addition postulate, you need to write it out. Because oftentimes people want to set everything equal to each other. They say, oh, I just set these two equal to each other. Well, there's nothing in this problem that says that this is a midpoint or a bisector. So I wouldn't do that. I would do part plus part equals whole. And if there's something in this problem that did say that they were equal to each other, I could set them equal. And that leads me to the example problem or practice problems. So on textbook page 14, so this is the introduction to 1-2 measuring segments. This is everything that we just talked about. I'd highly recommend looking over this as well. It goes into more detail than what my notes do as well. And here's some more key concepts. And then here's an example problem. Highly recommend looking over these example problems before starting on your practice problems. These tell you exactly what your answer should look like for these problems. So every time you come to a new problem, you should look back at the example problems. They're the ones in red, okay? It's the same thing here. Look at this. Someone might be tempted to just say, I'll set this part equal to this part. But there's nothing in this problem that says that F is the midpoint. So I cannot use midpoint bisector. That does not work. I have to use part plus part equals whole. So I can say this part plus this part equals this whole EG, which the problem tells me is 59. So that's how they set it up here. This part plus this part equals the whole. And you can see this is a more complicated problem, which is the exact reason why we want to set it up as an equation. The one I showed as an example could easily be done in our heads, but this one takes a bit more work, okay? So writing out the examples or writing it out as an equation is very important. And there's other example problems as well for any parts that you're struggling with. And same thing here. In this problem, it says that this is the midpoint. So I should think, oh, that means this is cutting these in half. That means both of these are equal. So I should make an equation with an equal sign. Equations have to have equal signs of that right there. Okay, so then we're still only on page 13. Our practice problems start on page 14. Always look for the blue practice. So page 14, 1 through 4, 7, 9 through 10, 13 through 15, 26, 27, 28. Now that may seem like a lot, but some of these problems are just, what is this length? Okay, and you can count those if you want to, or you can practice using some of the other methods. Maybe try one each different way. So that is that. And remember, all of the example problems have video explanations on the website, the textbook website.